Hello everyone, I hope you are doing well. In the previous video, we learned about what we'll be learning in this series and we went through the roadmap. And today we'll be learning why we need Docker, what is Docker, and the installation guide. If you are new to this video and haven't seen the previous video, please watch. And for all the new user, so this is a new Docker course we'll be having at like 10 to 12 classes where we'll learn everything that is required to get Docker understanding and how you can have confidence in writing your own Docker images and all of this. So this is for absolute beginner, and today is the introduction to Docker. But in the previous video, we gave you what the course will be about and what the roadmap is. So today is day two, where we'll learn what is Docker, why we need Docker, and we'll go through the installation steps. Okay, so let's get started. First question will be what is Docker. So uh, there are some time when you write an application, right, and it runs on your computer pretty well, everything works fine. But when you give that code to someone else and they try to run, it does not run because the platform is different. Suppose you're writing on Windows, okay, and you wrote everything works, then you gave it to your friend, he's using Linux system, and everything breaks and his project does not work. So to solve that type of issue, so Docker is introduced. So what Docker does is it ties your application, it puts in a basket, okay. So that basket becomes independent of your system. So your now it's not dependent on the system. It's in a basket where it will put the application. It will put all the libraries and whatever is required in the system, and it will run directly in this basket. So it will be isolated first, and secondly, it is not dependent on your system. So that is what Docker is. It helps you containerize a application so that you can share it with anybody without having a dependency of your operating system. So that is what Docker is. Docker is a way to containerize an application so that you can deploy fast, you can share, and there is no problem related to the operating system. And second question may be why Docker? So Docker is not the concept of Docker is not something extraordinary or something new. It's just an innovative way of doing what was previously done using concept of VM, virtual machine. So I hope you haven't heard of something called virtual machine where we can run an operating system in top of our operating system. So you have heard like we open run up a virtual machine of Ubuntu or anything in a Windows machine. So what was the concept was? Here we can isolate it from your system. So when you run a virtual machine in your computer, right? Anything you do inside virtual machine that is independent of your system. It will not hamper your system. It will just use up the resource, your hardware resources and everything. But it will not depend on your file system. So if anything goes wrong in the virtual machine, it goes only in that virtual machine. It will not have impact on your host operating system. So that was the concept of guest and host operating system and use of VM where we can isolate so that everything is protected in that virtual machine and your host have uh, there is no any repercussion on your host machine. So in the same concept, Docker was also introduced. But what Docker did is it did a little different of things where it does not run a guest operating system on your host of system. It uses your kernel directly. So let me show you an example. So here, let me show you first how VM runs in your system. Okay. So this image was taken from Free Code Camp Docker Handbook. So if please visit this website if you want to read an article about how Docker and how to run in a Docker. And this will be a video from, right? If you are interested in article form, you can visit this website. I'll link in the description. So if you see this, right, this is how a VM works in a basic way. In the most means how to know it more easily. This is the most easiest way to know how a VM works. So what VM does is first this is your application. Suppose this is a Flask application you're running. Okay, so this will be an application and you'll have the library like Flask and all this. So where this application will be, this application will be in top of a guest operating system. So in a virtual machine, when you start a virtual machine, you start a new operating system like Ubuntu, Debian, or a Windows virtual machine. So this virtual machine will have kernel of its own, right? These are all file based. Okay, every operating system of Linux is file. Everything is file. So it will have a kernel. So what if anything you perform on this application, right? This kernel will talk to something called hypervisor. What this hypervisor is a middleman so that your guest operating system can talk to the host operating system kernel. So this it will send a it will send a anything that was requested, it will send to this hypervisor. This hypervisor will decode this, it will send to your host operating system. So in this type of system, there is two operating system. One is the guest one and one is the host, that is where you are running this system. So what this does is this takes up a lot of space. Okay, first is space. Second, it takes your lot of resources. Why? Because this is a complete operating system. So complete operating system means what? It has a kernel, it has the application, it has the complete UI thing, that is a distribution it is running. So if it is running on Windows, it will have everything the Windows have, like this, all this, whatever you can see on your screen, right? It will have everything. In top of them, there is an application running. So it will use a lot of resources of your, and since there is a guest operating system. So now to overcome this, and but there's a benefit of it, okay? There is lot of benefit. Since it's a complete operating system, you can do lot of more things. You can do everything here, and anything you do here is inside this only, okay? If you do anything here, anything goes wrong, it goes wrong inside this operating system, and your host does not get impacted. So based on this system, Docker was introduced. What Docker did is it removed this operating system, the middle operating system. If you see, everything is same, application and library is there, but there is no Docker, there is no operating system here. So what Docker introduces, it will not have its own operating system, but it will use your host kernel directly. So earlier there was an operating system here, right? This will have a kernel. Now there is no kernel. What it will do is anything that is requested, it will request this Docker. This Docker will request your kernel. But since Docker was initially used for Linux, right? So what Docker needs a basic Linux system working Linux system. If you're running on Linux, there is no problem. But if you're running Windows, it's not meant to perform with Windows, okay? It needs a base Linux system. So what it does in Windows, there is something called WSL, Windows Subsystem of Linux. So it has all the basic capabilities of Linux. So you need to run a WSL so that Docker can perform, so that Docker can think it's talking to a Linux kernel, but Linux kernel sits in middle and talks with their host operating system. This is only for Windows and Mac. For Linux, it's completely like this. Anything is asked here, it will go to Docker. Docker will decode what it needs, and it will call the host operating system kernel. So how this is beneficial is first this is isolated. Okay, so if anything happens here, it happens here. Your host is not impacted. So that is maintained. It is on networking system like VM. So that is also there. It's just that it reduces your resources a lot. There is no operating system itself. So there is less resources, less storage, everything is less. And it performs the same capabilities. Of course, it will have some downside since it is not complete operating system, right? In VM, if you see, there's a complete guest OS. So there will have some disadvantage, but those are not so much needed when you wanted to just run an application to something. They may be needed for some cases. VM is absolute, okay, it's mandatory. But for Docker can handle most of the things that VM are not supposed to do that much of thing, which Docker can already handle. You should not go to VM because it will take a lot of resources, and Docker can easily handle that. So that is how Docker and VM difference. I hope you got the concept. So let me recap one. So in the VM system, there's a guest operating system, there's a hypervisor, and there is your host. Okay. So if anything is recommended by the application running, it will call this guest operating system kernel. This kernel will call hypervisor. Hypervisor will call kernel, and whatever is required from the infrastructure, it will just take up here. But in Docker, since there is no operating system, anything that's recommended, it goes to Docker. Docker talks to your kernel, and if any resources required, it will go back like this. Okay, this is lightweight, low on resources, and gives you the same capabilities like isolation, networking, and security, and all of this. So this is the concept of what Docker is, why Docker is, and how it's different from VM. I hope you got the concept. If you're still facing any difficulties or any concept is missed, please comment out and I'll try to solve it. Now let's go how to install Docker. Okay, to install Docker, you can go to this page called uh, https docs.docker. This one, and go here. Okay, and here you can see there is Docker for Mac, Docker for Windows, Docker for Linux. Based on your operating system, go here. For me, it's Docker for Windows. So I'll go to Windows, and you'll be seeing something like this. So download this Docker desktop for Windows and come back here, and it says install Docker. Okay, follow this step one by one completely. Don't do anything else. Just follow whatever is recommended. Just follow this, and you should get your Docker running. Okay, and if you are on Linux, then you can either download it from your package manager or go here, select your platform for Ubuntu, download the dep package, and follow the instruction that is saying. So the instruction is very simple. Okay, whatever they say, just follow it. Don't alter it for now since you're getting started. If you know what you're doing, then it's fine. If you don't know, just follow the instruction and everything should be running. If you face any error, okay, while doing this, if there is any error, please comment it. I'll resolve. After, if everything runs well, open up your terminal and just write docker dash v. Okay, it's docker dash v and run this. Now if you see anything like this, Docker version and the number and anything build like this, the number may be different. Okay, the build and number may be different, but that is not the case. That should not impact you. The main concern here is it coming this way? If it's coming this way, then Docker is installed properly and we can get started with Docker. But if you face any difficulties, okay, if you feel any error, please comment and I'll try to solve it. So yeah, that was the basic of what we wanted to do today. So we learned about what is Docker, why we need Docker, and how it's different from VM that is being used from a long time. Okay. So now if you go to the roadmap, you see from tomorrow we'll start learning the main things about Docker. Okay. We'll learn about images, container, Docker hub, and this. Tomorrow we'll learn a basic things. We'll give the overview of the concept, but later we'll start learning deep into it, like images, container. We'll start learning from deep. But tomorrow we'll give a basic concept of what Docker is and what Docker comprises of. Okay. So that was it for today's day two. That is why Docker is installation guide. I hope you understood the concept properly. If you're facing any difficulties, please comment and I will to solve it. So yeah, thank you for watching. See you in the next.